Intermediate Algebra for Statistics, using factoring to make predictions with quadratic models. Lesson objectives: use an equation of a quadratic model to make estimates and predictions. Model projectile motion in the area of rectangular objects. Lesson objective. Definition: a quadratic model is a quadratic function or its graph that describes the relationship between two quantities in an authentic situation. Example 1. The annual revenues of American Express are shown in the table for various years. Let R be the annual revenue in billions of dollars of the American Express in the year that is T years since 2000. A model of the situation is f of t equals 2/3 t squared minus 4/3 t plus 23.7. Number 1. Use a graphing calculator to draw the graph of the model and, in the same viewing window, the scattergram of the data. Does the model fit the data well? Number 2. Predict the revenue in 2010. Number 3. Predict when the revenue will be $39.7 billion. Solution: our first step is we want to enter the data in List 1 and List 2. List 1 will be the years since 2000, and List 2 will be the revenue. Next, we want to hit second y equals, which is stat plot. We want to make sure that the stat plot is on and it's set to scattergram. List 1 and List 2 is the defaults. Next, we want to hit zoom and number 9 for zoom stat. Here we have the graph. Next, we want to enter the function in y1 and see how well it models the data. So hit y equals, type in the model, then hit graph. Here we see the model with the data, and we can see the model is doing a very good job of fitting the pattern of the data. Number 2, predict the revenue for 2010. We need to find what is f of 10. So everywhere we see an x, we substitute a 10. We follow the order of operation. We square first, then multiply, and then we add and subtract, and we get 77.03. Now what does this mean in the terms of the problem? In the year 2010, the model predicts that the revenue will be $77.03 billion. To verify it using the graphing calculator, if we go to our table, when x is 10, y1 is 77.03. Number 3, we substitute 39.7 for f of t. Next, we subtract 39.7 to both sides, so the model will be equal to 0. Our next step is to get rid of the fractions, so we're going to multiply both sides of the equation by the least common multiple of the denominator, which is 3. So this multiplied by 3 becomes 2. T squared. This term multiplied by 3 becomes minus 4t, and minus 16 multiplied by 3 becomes minus 48. Next step is to look at all three terms and make sure that there's not a greatest common factor, and there is a 2. So we factor this out. We get t squared minus 2t minus 24. The next step is to factor this trinomial. What two numbers multiply to give me a negative 24 and add up to give me a negative 2? Since this is a negative number, the factors will have opposite signs, one positive and one negative, and it turns out that a negative 6 times a positive 4 is a negative 24, and negative 6 plus 4 is a negative 2. Now, using the zero factor property, either this binomial is 0 or this binomial is 0, so we set them equal to 0. And we see that t is equal to 6 or t is equal to a negative 4. So in the terms of the problem, the revenue will be $39.7 billion, 4 years less than 2000, which is in 1996, and 6 years since 2000, which would be 2006. To verify this using the graphing calculator, we use our table feature. When x is a negative 4, we have 39.7, and when x is a positive 6, we have 39.7. So the answer has been verified. Example 2. A batter hits a baseball into the air. The height, measured in feet, h equals f of t of a baseball at t seconds after the ball is hit is given by f of t equals negative 16t squared plus 96t plus 4. Number 1. When is the baseball at a height of 84 feet? Explain why there's 2 such times. Number 2. When is the baseball at a height of 148 feet? Explain why there is only 1 such time. Number 3. When is the baseball at a height of 150 feet? Number 4. Use the calculator to estimate when the baseball will hit the ground. Solution. Number 1. We substitute the output 84 for f of t, so this is our y value, and we're going to solve for t. So we have 84 equals negative 16t squared plus 96t plus 4. The next step is to subtract 84 to both sides of the equation. This will give us 0 on the left hand side of the equal sign, and we have this trinomial on the right hand side. Our next step is to make sure that there's no greatest common factors. Negative 16 will divide into each term, so negative 16 is a factor. Now when we factor out a negative 16, don't forget to change the signs. So we'll now have 0 equals negative 16 times t squared minus 6t plus 5. The next step is we want to factor this trinomial. So what two numbers multiply to give me 5 and at the same time add up to give me a negative 6? So since c is positive and b is negative, both factors will be negative. So we have the binomial t minus 1 times the binomial t minus 5. And by the 0 factor property, either this binomial is 0 or this one's 0. We set them equal to 0 and solve. We see that t is equal to 1 and t is also equal to 5. So 1 second after the baseball is hit, and again 5 seconds after it is hit, the baseball is at a height of 84 feet. This makes sense that there are 2 times because the baseball reaches a height of 84 on its way up and on its way down. To get a visual of this, we can graph it using the graphing calculator. We press window. Our x-min should be negative 1, so we can see the y-axis. Our x-max will be 7. We will count by 1. The y-min negative 25. The x-max 180. I got these values from first using the table feature. We hit graph, and we can see this is our parabola. And when x is 1 second, the height is 84 on its way up. And on its way down 5 seconds, the height again is 84. Number 2, we substitute the output 148 for f of t in the equation and solve for t. Just like number 1. First step, we want to subtract 148 to both sides. This gives us 0 equals negative 16t squared plus 96t minus 144. Factoring out a negative 16 gives us the trinomial t squared minus 6t plus 9. Next we want to factor this, and we get t minus 3 times t minus 3 times negative 16. Because the product of these 3 is equal to 0, either this is 0 or this is 0, and we have 2 binomials that are the same. So we take t minus 3, set it equal to 0, and we see that t is 3. There's only one value. So 3 seconds after the baseball is hit, it is at a height of 148 feet. This makes sense that there is only one time if the baseball reaches a height of 148 feet, only at the top of its climb. In other words, if the vertex of the parabola is when x is 3 and y is 148. So this is the maximum value for this parabola. This is at the peak. When x is 3, y will be 148. Number 3, since the maximum height of the baseball is 148 feet, the baseball will never reach a height of 150 feet. so it is outside the range of this function. Number 4, when the baseball hits the ground, the height, h, is 0. We want to estimate what is t when h is 0. So using the graphing calculator, if we press the trace key and follow it out to where h is close to 0, we see when x is about 5.98, the height is about 6 feet, and when x is a little bit more than 6, the height is a negative number. So it has to happen in between these two values. So if we use our table set, which is second and window, we'll start the table at 6 and we'll count by 0.01. We will look for when the height is positive and then becomes negative. So it is happening in between 6.04 and 6.05. So we would say, according to the model, the baseball will hit the ground at about 6.04 seconds. Quadratic models, parabolas, and equations. Consider the following observation about a quadratic model, parabola, and a quadratic equation. The previous example suggests that the baseball reaches each height either 2 times, 1 time, or never. In the video involving polynomial functions, it showed that for a parabola opening upward or downward, each value of y corresponded to 2, 1, or no values of x. We have also seen that a quadratic equation in one variable either has 2, 1, or no real solutions. Thanks for watching.